beads or 2 coins. You connect them on string, place them on table, and at the midpoint you start pulling it. That's what this numerical what we are discussing. That one. So what do you expect after as you start pulling? They'll try to move. No? So how do they move? They'll move in a plane. The disk, what happened? The A and B, they'll start moving in a plane. So the next related diagram. So put this, I think looking at least this diagram, you can manage the question now. So that the same force F is applied at the midpoint. So let this angle be theta. Length as usual, L/2. Now, will there be any tension in the string? Yes, there'll be tension. Look at the now role of the tension here. No, you look at from outside, not somewhere outside here. So what is the net force acting on the system? It's only the applied force, no? But the bead, what will happen? They will have velocity. The bead, what will happen? The disk will have velocity. The velocity of disk will be due to what? Work done by the tension only. So in what direction? The tension will have possible velocities. In what possible direction? It will have x component of velocity. Vx like this, and it will have y component. So here 2t cos theta, what is the string? The string is massless, no? Light inextensible chord of length L, so massless. So what should be the net force on the string? Should be 0. So the very first equation, I will write it as F minus 2t cos theta equals 0. So now we have information regarding tension. How much? F by 2 cos theta. So tension, this thing, will it be constant? No, it depends on theta. Okay, there's a one thing. No, what to do? How to bring that? Is asking what is the velocity of approach of the disk when they are about to collide. When they are about to collide, so almost what will be the state of theta? Theta will be almost equal to 0. Just 0.01 degrees will be there. So the disk will be there in this position. Okay, the string is almost about to collide. So bring it very nearer. And the string is almost horizontal, or it will make small angle, and the theta will be almost equal to 0 only in our sense. So here now they're about to collide. So now he's asking what is the relative speed between them. Okay, let me define some conditions here. So this is a y, this is L. So here from the triangle, this is x, L/2, theta and y. So what is sine theta? Let me focus on method. Sine theta equal to y L/2 or y equal to L/2 sine theta. I'll differentiate. Dy is equal to L/2 differentiation of sine theta cos theta d theta. So now what will happen to this y? So as you can see that one, as it moves, what happens? The theta decreases. No, theta is increasing or decreasing? It is decreasing. That you keep in mind. Let's come for who will produce this velocity, y component of velocity, the component of tension only. So what component of tension will make the particle A to acquire velocity Vy? The vertical component t sine theta. The t sine theta is what responsible for the increase in speed of the disk along y-axis. So let's get into the work done. Already we have information of tension. So then dw, work done by the tension, work done by the tension, y component of tension, work done by the y component of tension. This should be equal to how much? T sine theta into dy. Now what should be the limit? Initially, how much this angle? Theta 90, no? Finally, how much theta has become 0? So what should be the limit? Limit should be pi by 2 to 0. The limit should be, what is the value of theta? What is the value of tension? F by 2 cos theta. Look at now, dy is decreasing, no? Dy is decreasing. So therefore, here in the limit, here substitution, I'll put minus d theta. This is very important. Sir, how do we come to know? Look at this. What is theta? From 90 it is becoming 0. So already you have taken care. Already you have taken care. So these are some mathematical things. Huh? So you solve the problem. Somewhere you'll end up with answer. The work done, the work done by the tension on the particle A and B is positive, no? Because of that only speed is increasing. So why this negative sign? Negative sign is dy. We are writing this one. It's not that work done negative only.
Sir,
So now substitute all this.
sir, won't it be f by 2 cos theta sin theta into L by 2 that?
Sin theta I'm missing, no? Yeah. So this further, the equation will be f L by 4. I'll take it outside. Integral of pi by 2 to 0 minus, okay, this negative sign, let me bring that also. Sin theta d theta. We'll see what is the role of that minus sign. Let's not bother much. Integral of sin theta is what? Cos theta minus cos theta. Pi by 2 to 0. Okay, now see this FL by 4. Cos 0 minus 1 minus 0. So therefore this should be equal to how much? FL by 4. In fact, the work done by the y comp t sin theta does positive work. That's what to indicate that is what this sign is brought here. Okay, now we got this much. Okay, how to get that? Is asking something relative speed, no? So what shall I do with this? This should be equal to WTY should be equal to WTY should be equal to MVY square by 2, no? On individual disk, it will does this much of work here. Then after getting this one, what is the relative speed should be equal to Vy. Y again negative of this will be. Because you see that finally they're approaching each other, no? What is the relative speed? 2 Vy. Look at the y component of velocities. 2 Vy. So substituting this one will get answer. I'll get Vy as 1 meter per second after solving. This will be 2 meter per second. Okay, this is about the string one. The work done by the tension in the string. I'm just introducing to different cases. Just do remember. Okay, just